I am Dr. R. Palanivelu, Professor of Chemistry, K.S.Rangasamy College of Technology, Tiruchendur. Today, I would like to handle the topic on basics of electrochemistry. What is electrochemistry? It is a branch of chemistry which deals the relationship between the electrical and chemical energy. That means how the chemical energy is converted into electrical energy by using various devices. This is nothing but electrochemistry. So before we look into the electrochemistry subject, we will discuss about the fundamentals, some fundamentals of the electrochemistry. First of all, what is conductor? Conductor is a material or a substance which are able to conduct electricity. For example, all sort of metals. Next one is semiconductor. They are partially conducting the electrons. That means in between that of conductors and insulators. Example, semiconductors, silicon, germanium, bismuth, antimony, etc. What does mean insulators? They are certain substances which are not able to conduct electrons. They are said to be insulators or non-conductors. Example, mica, plastic, rubber. That too, nowadays polymers are somewhat conducting materials because they can conduct conducting segments. By using that segment, lot of polymers are able to conduct electricity nowadays. Then some terminology in electrochemistry we'll discuss one by one. The types of conductors. What are the types of conductors? There are two types of conductors. One is metallic conductor and another one is electrolytic conductor. What does mean metallic conductor? Metallic conductors are solid substances which are able to conduct by means of valence electrons. They are said to be metallic conductors. Example, all sort of metals and non-metals like graphite. Then electrolytic conductors, they are substances or conductors which are conducting electricity only by means of solution. So they can dissolve in suitable solvent and make it as a solution, then only it will conduct electricity. Such conductors are called as electrolytic conductors. Examples, acids, bases, then electrovalent substances like sodium chloride, potassium chloride, sodium hydroxide, etc. Then next one is types of electrolytic conductors. So it has three types of conductors. One is strong electrolytes and another one is weak electrolytes and non-electrolytes. What does mean strong electrolyte? There's a solution which is able to conduct electricity and ionize very quickly is known as strong electrolytes. Example, sodium chloride, sodium hydroxide, potassium chloride, sulfuric acid, hydrochloric acid, etc. Then weak electrolytes, there are some certain substances which are not able to ionize completely in a solution. So they can conduct electricity only very feeble manner. Such conductors or electrolytes are called as weak electrolytes. Example, acetic acid, ammonium hydroxide, sodium acetate, etc. Then non-electrolytes. What does mean non-electrolytes? There are certain solutions which are not able to conduct electricity. They are said to be non-electrolytes. Example, kerosene, diesel, petrol, sugar solution, etc. Next one is cell terminology. What is cell? Cell is a device in which the electrochemical redox reactions can be carried out. The cell consists of one anode, cathode, then which are connected by means one salt bridge. What is salt bridge? How can you make it? Salt bridge is a device which is simply we can make it by using filter paper and is soaked into a saturated potassium chloride solution and kept between the both anode half cell and cathode half cell. So the purpose of connecting that salt bridge is only it doesn't conduct any ions from anode to cathode. It is a just connecting medium. That's all. What is current? Most of the people are thinking that current is nothing but movement of electrons. It's not correct. Current is nothing but movement of charged particles. Then what does mean electrode? Electrode is a metal or non-metal rod which conducts electricity. That is called electrode. Then what is anode? Anode is the electrode at which oxidation occurs. What does mean oxidation? There are two definitions for oxidation. One is electronic aspect and another one is chemical aspect. According to electronic aspect, oxidation is nothing but removal of electrons, and chemical aspect addition of oxygen. Then what does mean reduction? Just opposite. As per electronic aspect, gain of electron is nothing but reduction, and removal of oxygen followed by addition of hydrogen is nothing but reduction. Then what does mean cathode? It is a electrode at which reduction occurs. So already I have told the definition of a reduction. Reduction is nothing but gain of electrons in electronic aspect and addition of hydrogen followed by removal of oxygen in chemical aspect. Then what does mean electrolyte? It is a water soluble substance forming ions in solution and conduct an electric current. This is nothing but electrolyte. What does mean anode compartment and cathode compartment? A cell, already told that there are two half cells, one is anode half cell and another one is cathode half cell. So we can say that the anode half cell is nothing but anodic compartment, and cathode half cell is nothing but cathodic compartment. Anode compartment is the component of the cell in which oxidation half reaction occurs. It contains the anode. At cathode side, the reduction takes place, so that is always in the right hand side. So what is cell? So we have discussed so far what is anode, what is cathode, what is electrolyte, and other basic things. Now we can define cell. What is cell? Cell is a device in which the electrochemical redox reactions can be carried out. What does mean redox reactions? Both reduction and oxidation takes place simultaneously in a particular device is nothing but redox reaction. Next one is electrode potential. There are certain terminology in electrochemistry. The one is electrode potential. So what does mean electrode potential? The tendency of metal which undergo either oxidation and or reduction when it is dipped in a own salt solution. This is nothing but electrode potential. There are several kinds of electrode potential. We can say that oxidation potential, reduction potential, standard oxidation potential and standard reduction potential. So let us discuss one by one. What is oxidation potential? Very simple oxidation potential. When the metal is dipped in own salt solution which undergoes oxidation, that means removal of electrons in a dipped in a own salt solution. This is nothing but oxidation potential. Reduction potential, the tendency of metal which undergoes gain of electrons when the metal rod is dipped in own salt solution. This is simple reduction potential. What does mean standard electrode potential at standard conditions? The same definition at standard conditions. Standard oxidation potential, it refers to the tendency of metal which undergoes loss of electrons when the metal is dipped in own salt solution whose concentration is 1 molar at 25 degrees centigrade. That is a standard condition, that is 1 molar condition, solution at room temperature 25 degrees centigrade. This is nothing but standard oxidation potential. What does mean standard reduction potential? The same definition what we have discussed for reduction potential at standard conditions. The tendency of metal which undergoes gain of electrons when the metal is dipped in own salt solution whose molar concentration is 1 molar at 25 degrees centigrade. So this can be explained by the following procedures, experimental procedure. When the zinc rod is dipped in zinc sulfate solution in a separate beaker, which is placed in the left hand side. So normally when we write the cell construction, we should write the anode at left hand side and the cathode is right hand side. The two half cells are separated by means of double vertical line, which is nothing but salt bridge. So that's what we have tried the cell notation, and similarly we can place the anodic compartment in the left hand side and the cathodic compartment in the right hand side. The anode side, zinc metal is dipped in zinc sulfate solution whose molar concentration is 1 molarity. Similarly, the copper metal is taken as a cathode and is placed in a copper sulfate solution whose concentration is 1 molar at 25 degrees centigrade. Next slide. So this is the simple schematic representation of electrode potential. So see in the left hand side, see that a zinc rod is dipped in zinc sulfate solution whose concentration is 1 molar. Similarly, in the right hand side, copper metal is dipped in copper sulfate solution, it's same concentration. Now, the two half cells are connected by means of metallic wire or by means of salt bridge. Now, when the zinc rod is dipped in one salt solution, what will happen means the zinc ions are moving into the solution from the metallic rod and leaving behind the electrons over the metal rod. That's why the zinc rod is marked as negative. Hence, it is called as anodic metal. Similarly, the copper electrode, the copper ions present in the solution attracted by the copper rod, because from the zinc electrode the electrons are moving towards the copper electrode, hence the copper rod gets more electrons over it. So, the copper ions present in the solution get moving towards the copper electron deposit over it. See that the zinc rod, the electrons are accumulated over the rod, these electrons will move to the copper electrode through the wire. In this case, the right hand side, that is copper sulfate beaker, the copper ions present solution attracted by the electrons coming from the zinc electrode on the copper rod. Hence, a double layer is formed. See that in the zinc electrode, negative and positive double layer is formed. Here the copper electrode, positive and negative double layer is formed. Hence, this double layer is known as Gibbs-Helmholtz double layer, because this experiment was done by the scientist namely Gibbs-Helmholtz. Next. This is not layer of positive or negative, that's what I explained earlier. That layer is called as Gibbs-Helmholtz electric double layer. So, from which we can define the cell potential is nothing but the left hand side anodic compartment, that is oxidation taking place normally. So, that the right hand side normally the reduction takes place normally. So, the oxidation potential is nothing but the tendency of metal which undergoes loss of electron, which was taking place in the left hand side, that is zinc electrode. So, hence it is called as oxidation potential. Similarly, in the right hand side the reduction taking place, that means gain of electrons take place, that is nothing but reduction potential. Standard, already I told that the same definition, at the end of the definition we can add it 1 molar concentration at 25 degree centigrade. Next, factors affecting the electrode potential. What are the parameters which affect the electrode potential? There are normally 3 parameters. One is the nature of the metal. If the metal is very pure, so it can conduct electricity very fastly. If it is impure, that is some impurities may be there, so it will prevent the movement of electrons. Then the temperature. So, already I told that the temperature plays a major role in the electrochemistry, especially in the metallic conductors. When the temperature rises, the electrons will be forbidden at a higher temperature. In the as well as the electrolytic conductors, when the temperature rises, the conductance also increases. So, that is the difference between metallic and electrolytic conductors. The temperature also plays a major role in electrode potential. Then the concentration of metal ions in solution. So, that is what I told. We have taken the 1 molarity of the salt in a solution when we prepared both zinc and copper sulfate. If the concentration rises, the electrode potential also rises. So, with this I would like to conclude my session. Thank you very much.